Hello there. Thank you for coming to my talk today here on Festive Tech Calendar. There have been so many great talks this year, and I'm grateful that you have decided to watch mine as well. My talk today is called Buried in Technical Debt, Making the Right Investments in Your Code. I will be talking about what is technical debt, how to know when we have it, what we can do about it, and I'll even have some code samples to illustrate as we go. So my name is Chris Stone. I have been engineering software and leading development teams for 7 years now. I'm currently a software engineer at Immersion, which is a language assessment company in Utah. I myself live in the metro Atlanta, Georgia area, and you can see me every month at the Software Crafters Atlanta meetup. My website, chrisstone.dev, has the slides and the code used in today's talk, so feel free to check that out. Also, my username is chrisstonedev on multiple social profiles, such as Twitter, GitHub, LinkedIn, and more. I appreciate getting to learn from other people in the software community, and it's the best way to contact me if you have any questions or want to reach out. All right. Let's get started. So 2021 is coming to an end and the new year is approaching. I like to think of New Year's resolutions every year. Not all of them stick, but it's nice to consider a fresh start and set aside some time for reflection. When people make New Year's resolutions, usually they're centered around some common themes, such as exercising more, getting to meet new people, or getting a better handle on finances. And many people have some form of debt that they are working on paying off. And maybe this is particularly true if you just bought some pricey holiday presents. Now, does anyone have a New Year's resolution to address their technical debt? Do you know what technical debt is? We'll see if maybe I can inspire you to make a technical debt New Year's resolution for next year. So to start things off, just what is technical debt? I'll get to that in a minute, but first, let's take a minute and review what is debt. Well, sometimes we choose to take on debt. Maybe we want a new car, but we can't afford to pay it all outright. We take a shortcut. We know we will have the money, so we sign up for monthly installments. We get to have the car now, and all will be fine as long as we do make those monthly payments. And, well, a new phone would also be good. And we needed to get some good holiday presents, right? Buy a new TV, credit card debt. If you're not careful, it can pile up into an unmanageable mess. So what does that actually have to do with programming? Why would we ever compare writing software to debt? Who would do such a thing? Well, Ward Cunningham would. He is credited with coining the debt metaphor in a 1992 paper where he said, shipping first-time code is like going into debt, and a little debt speeds development, so long as it is paid back promptly with a rewrite. But every minute spent on not quite right code counts as interest on that debt. In other words, again, sometimes we choose to take on debt. We take a shortcut and trade a higher quality solution for a faster delivery. All is well and good when you take on that debt, assuming that you make the monthly payments. But maybe this continues to happen. We're putting out fires and not giving ourselves time to reflect on the work that we're doing. Maybe we don't prioritize the necessary upkeep. And if we're not careful, it can pile up into an unmanageable mess. Sure sounds bad, doesn't it? Well, how can you know if you have technical debt? Well, here are some signs that you may have technical debt. We start again with taking shortcuts. Someone needs something very quickly, so we do something that maybe isn't the best solution out the gate. The team always has to make last-minute changes. Scope changes too frequently. Components are tightly coupled, especially where business logic, user interface, and database calls are all mixed in together. Code is hard to read. Variables and methods are not named well. Methods are too long and complex, and it's not clear what the code is meant to be doing. The team is afraid to touch an area of the code because, well, it just works. And if I look at it the wrong way, I might cause it to malfunction. There's no documentation, and other teams that rely on your code have nothing that they can reference. The team's not cross-training, and there are knowledge silos where only certain people know how certain things work. Even worse, maybe you had a knowledge silo and that person won the lottery and they quit and they took all their knowledge with them. Maybe there's a lack of leadership and no one is really sure who actually owns and is responsible for parts of the code. There are no unit tests, the unit tests don't get run, or the unit tests don't cover enough of the solution. So you can't easily and safely verify that the application is running and functioning as it should. Concerns from engineers are not taken into account when planning work. Dependencies on which the program depends to stay secure and modern are out of date. Maybe even the whole platform on which your app runs is outdated. You know, it's said that a car loses value as soon as it's driven off the lot. And it can feel about the same with software sometimes. If you use third-party libraries, it's important to track updates on these. You'll often find security updates, and you may even find feature updates. So did any of those hit close to home for any of you? I know when I joined my first job after college, I did not imagine I'd practically face any of these challenges, but I've seen basically all of them to some degree at some point. But it's okay if we just see some of these issues occasionally, as long as we do address them eventually and we make the minimum payments off that debt and don't allow the principal to grow far greater than what it was initially. The key is we don't want issues like these to multiply and become worse. So let's talk through all of these again. I'll go through them all. And we'll spend some time talking about how we can spot them so we can see how they originate, how they can expand so greatly, and maybe even how we can make some resolutions on those issues now. So first of all, say the engineering team is often taking shortcuts to get quick fixes out and rarely going back and doing things the correct way. Let's see one way this might manifest. Is anyone familiar with the concept of planning poker? It's not something that all software companies do, but some teams use this as a tool to find a common understanding between engineering and product management groups. A product manager presents a task that they would like to be completed, and all engineers have a hand of cards based on the Fibonacci sequence. All at once, they reveal the number of story points they believe the task should have and look for consensus and on what number the team can agree. And if you're not familiar with story points, by the way, just know that it is a relative measure of complexity and not necessarily correlating to a specific time measurement. It's an estimation tool to describe difficulty and uncertainty comparably to other items. So if you find yourself in this situation, though, be careful of situations like this. The product manager wants a big new feature. It's huge, and it's going to affect a lot of parts of the code, including parts that people are usually afraid to touch. So you put a 20 down. There are gasps in the room. Sure, it's a pretty big feature, but the product manager thinks you're being a bit harsh. They promise you that the scope is limited, and there's no chance that you'll need to do anything more than they've already called out. Okay, well, maybe you're convinced to rate it a 13 now. It's still the highest estimate in the room. Another engineer brings up that we can avoid having to write a new database table by storing the new information in files that we'll store on the customer's server. It's not ideal, but it's clear that the customer would like this feature as soon as we could possibly ship it. Fine. If we do that, then this is just an 8. But there's even more negotiating. If we don't want to have to package up an official software update, we can have an engineer build the DLLs and EXEs and when they think it's ready, and they'll put it in their personal Dropbox account. This doesn't sound right at all. I'm really concerned about what I just heard. But you don't want to be seen as the person who said it couldn't be done. You're just as customer focused as everyone else on the team. You go along with it. Sure. Fine. If we do all that, it's a 5. Great. We're good with this item going in the sprint now. The team acknowledges your concerns and promises you we will go back and do this the right way when we have the time. This kind of stuff happens and it's okay. But then the next item goes like this. And here we are again. Apparently, this item is just as much in a rush as the last one. You know, what I love about being a software engineer is the challenge to look for alternative and innovative ways of solving problems. And it's always a good thing to be thinking about the end user of the application. And there are honestly emergencies that come up when we need the quickest path to a solution as possible. But if the innovative solution is going to cause us headaches in the future, don't be afraid to defend taking the time to do things the right way. In fact, if the area we need to improve has some technical debt, this is a good reason to spend not less, but additional time so we can bundle some technical debt payments in the related areas and leave the code in a better state than before. Bundling technical debt mitigation as features and fixes are requested in their areas is key. And maybe it takes more time than the product manager was hoping, but it could help us go faster in the future. Imagine you are on a house construction project. You are asked about a job, and it is something you have done before, so you know this will take 4 days. Turns out the homeowner wants something more quickly, and they beg and they plead. Isn't there any way that this could be shortened to just 1 day of work? Without increasing the cost, of course. Maybe there's some mistrust among your crew, thinking that 4 days is your way of padding out time so you could get paid more. You want a good review, so you consider your options, but you take pride in your work. Trying to get this done in 1 day will probably require slapping a bunch of things together that will require that you go right back out a few more times to fix up. Now, I want to be clear. You don't want to overinflate your estimate and promise, say, 30 days just to be sure. They would see you as too expensive an option and take their business elsewhere. But you do convince people that doing this the right way and the least expensive over the long term means taking the time to do it the right way in the beginning. Another thing we mentioned was having too many last-minute changes, also known as scope creep, because the scope of the item keeps increasing beyond the original state. Remember that item in Planning Poker, where in planning, we convinced the team to spend the time necessary to do certain things. We talked through it as early as possible. But maybe it got someone in the company thinking about other little improvements. Well, little improvement after little improvement, and this is way too big of an item now. With deadlines, we might even feel pressure to take some things out. And which ones seem like the first to go? That's right. Again, if we go back and do this later, that's fine. It can even be healthy to do things the right way the first time, to get it to do it even a fast way, to get it out as soon as we could do it, and then worry about some refactoring later. Because otherwise, if you always make sure that the architecture is as best as possible, you might end up with architecture that's way more than you ever really needed. But you need to make sure that the refactoring does eventually happen. Too many last-minute changes can throw things off for teams. Data and UI calls being commingled. Take this code example. If an error occurs, this one class has direct access to a UI component to set the text to let the user know what happened. But this code comes from a network event, and it might not even be the UI thread that we're currently on, meaning we're potentially running into a cross-thread operation. It also has direct access to a file that is used as a log, meaning this class has to handle file I/O issues, because that file might have been locked for writing at some point. Then we send data back over the network. But what if there's an issue with our network connection? Something slowed down or got disconnected in the time it took us to get here. Clearly, all of these potential scenarios should be considered and should be handled. But that try-catch handling would be huge for this one method. This would be much easier to maintain if we sent the data that these processes needed to be aware of using something like events, so that classes whose primary function is to do UI or to do network or database or file I/O calls can implement their own error handling specific to the responsibility that that class has. Code is hard to read. Code is eventually compiled into a language that the machine will need to understand, and only the machine. So making sure that the code that you write is easy to read for the next person is very important. If they don't know what the intent behind your code is, or if you have methods that are hundreds or even over 1,000 lines long, that will be very hard to maintain. It adds complexity to even minor features that are needed in those areas in the future. Code that no one understands. Maybe there's an entire module in which people do not usually maintain the code, so when they're asked to do so, they're afraid of breaking something that, well, just worked earlier. This is especially true when you work in code where variable and method names are needlessly abbreviated. Like this example here. What does all this mean? Someone felt the need to keep variable names within 3 characters so there's no vowels, and there's some initialisms. Programming languages don't typically cost you any extra to label your variable with a descriptive name. It will really help the next person who has to review or maintain your code. There is no documentation. If your project has a public-facing API, this is especially true. How can you expect people to know what to call and how to correctly call it if they do not have good documentation to reference? And bad documentation can be harmful too. If you do not change your documentation at the same time that your interfaces change, people might not be calling your API correctly anymore. So this is a part of maintenance for that project now. Also internally facing, if you use comments in your code, be careful with those as well. Whether they are comment lines or descriptive variable or method names, it is possible that someone can make a change without changing those names or those comments, and the intent behind the code just became a lot less clear. Make sure that you write code in ways that are easy for the next person to read, and do not leave comments that have become irrelevant in the code. The team is not cross-training, and there are knowledge silos. Have you ever been in a team that identified a very high priority item to be worked on, but everyone decided to set it aside for the day because no one could discuss it until the subject matter expert returned from vacation? This is a red flag. It is wonderful when a team is made up of people with different strengths who can come together and share something and create a new application that no one person could have created on their own. But there should not be an entire section of the program that people are afraid to touch if the need came up. So keep an ear out for situations such as those to see where some people may be the single knowledge holders on a team. One thing that we do at Immersion is mob programming, and we do it remotely with developers in different time zones as well. Only one person is typing code at a time, but groups of developers get together and talk through the problem and navigate how to solve it. This way, if the person who is the subject matter expert needed to take a sick day, the rest of us can continue to pick up that work because we all learned as we went. And this is just one possible way of getting through this problem, but also dedicating time to cross-training and maybe having someone work together and do pair programming or work on writing documentation for how I was able to do this so the next person can maintain it is very important. There is no leadership. This could refer to uncertainty over who actually needs to take ownership of a certain area, or maybe the person who has taken ownership is not leading it very well. So let's consider a kitchen. Everything is in its place. I come in because I'm hungry. That's my primary motive for being in this room. That's the top priority. So I'm feeling festive, and I pull out a pan and start frying up some potato latkes. I put it on a plate, and I place the plate in the sink when I'm done. Might be a good idea to clean it up, but I got a Slack message. Someone's having a technical issue at work. Something about they're trying to debug and the symbols aren't loading. So even though I'm on my lunch break, I head out of the kitchen and back to work to help them. I do come back to the kitchen later though, because I'm hungry again. I realize that I left a mess. I took a shortcut and took the quickest path through the kitchen. I could spend some time cleaning up now, but my primary motive again is I'm in here because I need to eat. To get the most out of my time, I need to eat. That's how I'm going to provide the most value. It is the top priority. So I pull out a new pan and fry up some more latkes there. I chop up some cilantro and onion over to the side. I'm noticing that the wall is starting to look a bit grimy from the oil splashing, but I don't have time to clean. I need to eat. I plate my food and then put my plate in the sink when I'm done. I leave the kitchen because it occurs to me, hey, I could spend the rest of my lunch hour sorting my sock drawer by color. So I leave the kitchen to go do that. But I get hungry later. It's important to clean this up, but it's urgent that I eat. So I take out some bread to make some toast, put it on a plate, put that plate in the sink. Oh my gosh, this place is filthy. But how can I justify cleaning this room as the most important thing that must be done? Plus, it's really going to take some time now, and I don't have the time to spare. I insist I'll come back and clean this when I get the time. Well, I come back, all my utensils are dirty, and I'm so hungry. So I get some chips and salsa. I eat what I can until I'm not hungry. I put my plate in the sink. Wow. If I didn't have time to take on cleaning before, I really don't now. By the time I come back, it's too late. I'm out of plates that don't have grime. I'm out of ingredients that don't have mold. I'm out of utensils that don't have rust. I order pizza, and next meal is also pizza. So I'm probably going to make myself sick with all of this stuff in the house. There's dust everywhere. I'm not even sure I can live in this house anymore. Who wants to clean this huge mess? This is a major undertaking, and now it is urgent before I do anything else that I do a deep clean of my kitchen. But it didn't have to be this way. What if I could go back to how this all started? And what if I had made sure that the importance of cleaning the plates and the pans as I went was done? And it doesn't have to be after every little thing. You don't have to sweep the floor every single day. Maybe just sweep the floor every few days. I don't have to wipe the walls clean every day. Maybe just once a week. There's a schedule and a cadence that I can do some maintenance so that every time I go into my kitchen, it's ready for me and it is faster to cook what I want to cook because I did what I had to do ahead of time. Here's a decision matrix that is used for time management. It goes by several names, but it is a useful tool if you find yourself with many to-do items and you need to sort through them to determine the best path. Determine for each item how urgent it is and how important it is. So in that previous analogy, feeding myself was both urgent and important. It's important that I eat for my physiological health, and it's urgent because I'm not going to be my best self if I don't address that physiological need. That Slack notification was urgent but not important. Someone at work did need help, but I was on my lunch break and I could have taken a second to delegate that task. Someone who's not on their lunch break, see if maybe they are available. Or go back to the person having issues and see if there's some other things they can try before I jump on myself. Sorting the sock drawer was neither urgent nor important. This was completely safe to delete from my to-do list and not work on at all. But cleaning the kitchen was not urgent most of the time, but it was always important. It became urgent at the end, and now I had to push some things out that I wanted to get done because of just how urgent cleaning became. But if I'd scheduled time to work on it before it got in that state, I could have handled it at a cadence I could handle and was more manageable. So, what was the purpose of this whole analogy? Because I'm telling you that your technical debt is here. Your technical debt is important, but it's not urgent. And if you don't address it, it could end up becoming urgent. Sometimes this matrix is written so that every item in there has a verb that starts with D. So sometimes for this, they call it delay it or defer it. But I didn't use those because you could delay it forever. You could defer it as long as it doesn't seem like what you should be doing. But you need a plan which you know that you can stick. And that plan should be regularly occurring. In fact, what's the right amount of time that every software team must spend on technical debt? Any guesses? Maybe it's 20%, 35%, 10%. Well, it's up to your team to decide based on the needs that you have. And any number is better than zero. 20% is a number that's been used on multiple teams I have been on, but there are reasons to prioritize it more or less as needed. And sticking to a strict numeric target and recording metrics and trends on this doesn't always make sense. Just make sure that you incorporate technical debt mitigation on a regular cadence. It should be a regular habit for software teams, and anything is better than zero. So, what if my software product has no unit tests? If we're not testing our work, then how can we quickly know that we are not making things worse as we work on them? This test pyramid is often used as an illustration. Mike Cohn is credited with creating it. And it is essentially saying that an ideal testing solution is it's okay to have all of these kinds of tests, but as you go up, there should be fewer because the focus should be on faster feedback. When refactoring to address technical debt, this is very important. If you do not have any unit tests, it might be difficult if the platform your code is on does not support unit tests, or if the code is doing too much at once and it is difficult to separate specific units of code. But where possible, see if it makes sense to write a unit test first for the existing functionality. Then you can feel free to refactor and clean that code up some more, because your unit tests will continue to fail until you get it right. Fight the temptation to change the unit test too much during this process, because if you have a difficult time getting your failing test to pass again, it might be a key indicator that it's time to rewind and try a different strategy. This is how test-driven development works and can help you with large code changes. Concerns from engineers are not taken into account when planning work. So not only is this relevant for how technical debt grows, but it also has a negative effect on teams that know that they have technical debt and feel that it's stagnating their product. So according to a report published earlier this year, over 200 engineers, engineering leads, and CTOs were surveyed, and they found that over 65% believed their technical debt was causing quality issues. 63% said it slowed down their development pace. And 52% said it impacted the engineering team's morale. Why is that? Maybe because, on average, survey respondents felt they spent about 7 hours a week, about a full day, just on dealing with technical debt, plus another 6 hours on other maintenance work. So 1/3 of their job is just trying to address issues based on problems that they know are there. It would likely take less time overall to tackle the technical debt head on and move forward than face the daily and weekly challenges that come up from having these problems. And why do they face these challenges? 58% of respondents said their company had no process to manage their technical debt. So engineering teams are spending 1/3 of their time fixing issues that they know are there but have no process or are not satisfied with their process of handling it. So let's say that the engineering team has identified a large amount of technical debt. How are we going to justify to upper management that we need to address this? Well, we start by convincing them that new stuff is fun and we want to have fun. We want to be doing all of the latest trendy development things. Well, I'm sure that is the case, but it's important to be pragmatic and understanding. You may have a strong opinion about a framework that a team is using, but if it is working for them, then listen and be understanding. Make sure that you understand this. Technical debt is not code I don't like. If you need to advocate for a large technical debt spend, make sure that you're actually providing good justification using value terms that the business can appreciate. Maybe a customer needs a feature that we can only help deliver with significant rework or being on a better platform. Well, in that case, they might be willing to pay for a custom project that will handle the spending concerns. Maybe a customer needs better security. The program might be using an open protocol, and an enterprise customer might have specific network security requirements, for example. Well, until these are fixed, this could be a barrier to selling to new customers. Maybe the company's having a hard time hiring new engineers that are super experts in a very niche field. And maybe keeping the program modern will help attract more people to work for the team and can help you retain the people that you have now. Maybe the current state is giving customers a lot of headaches, and addressing that debt will improve the relationship that both customers and a customer service team has with the product. So part of the battle is to figure out where you have technical debt, communicating that with others, and putting it in a palatable form that people across the business can understand is vital when you have large pieces of technical debt, which we're about to get into. Because the next item is outdated dependencies. Dependencies the program needs to stay secure and modern are outdated. If you use third-party libraries, it's important to track updates on these. You'll often find security updates and may even find feature updates. Imagine you have an Angular 2 project and you wanted to update to Angular 4, but there are some steps you will need to follow to make sure that you do it the right way. Maybe some of this can be bundled as we work in this area. This really isn't that long, but let's just say the team chooses to work on other things instead and come back later. The conversation comes back up when Angular 8 comes out, and the checklist is now significantly larger. Well, this settles it. This task is too large now. It might not even fit into a single sprint. Well, if everything falls into place someday, maybe we will look into it, but not yet. Well, version 12 of Angular came out earlier this year, and this is your checklist now. So we didn't make the minimum payments on our technical debt, and it is just too large. This might be a project that without significant willpower from stakeholders does not get done. Maybe a new version comes with features that we could really use to complete a feature request, but the preparation to do this update is gargantuan. And that was true when I first wrote this slide, but since I wrote this slide, Angular 13 was released, and this is your checklist now. So you accept the fate that your app might just be stuck in Angular 2. Just from not updating the project occasionally, we incurred technical debt and we didn't make the minimum payments. Our annual percentage rate increased, and even if we start paying off this debt, we'll likely be paying it off for quite a long time. Some teams will put off tasks like this because they just keep coming back and can be time consuming. And what if you do actually get the desire to tackle this technical debt in a major way? It's going to take a lot of convincing of internal and maybe even external stakeholders. You'll have to cross your T's and dot your I's. Explain how the funding is justified and why we need to take action. Even worse than outdated dependencies, though, you might be on an outdated platform. The very platform on which the program exists is outdated, out of support, and you have a situation that is frustrating for everyone. Maybe it's still on Visual Basic. And when I say that, I don't mean the language that Microsoft has continued to update, is open source, compiles to multiple platforms using .NET, and can be written using multiple operating systems. No, I mean the old Visual Basic. Hasn't seen a patch since 1998. 1998. For some context, 1998 is when The Legend of Zelda: Ocarina of Time first came out. And the big thing on TV was the series finale of Seinfeld 23 years ago. And you don't get .NET. Instead, it's based on COM, which means the programs are stuck on Windows 32-bit forever. In fact, the IDE isn't even supported anymore. Hasn't been since 2008. In annual surveys conducted by Stack Overflow, it was rated the most dreaded programming language every year from 2015 through 2018. Why only now? And why not since? Well, these were the only years that they asked that question and had classic Visual Basic as an option. The software industry is a constantly evolving field, and a program still targeting VB6 is stuck in the past. If you can get around the IDE support, VB6 programs will actually still run on Windows 11. But if this technical debt is going to be picked up by the team, something substantial will need to be done. It might even require a full rewrite. I know. This is a very scary area, not a problem you want to find yourself in. Many full-on software rewrites fail. Trying to completely port an app from one platform to another might leave a team supporting both versions forever. The goal is to make the new version functionally equivalent to the old one. But there's always something weird about the new program that makes users who are used to the old program hesitant to ever make the jump. But there is hope. It might be worth considering partnering with a team who is used to these kinds of problems and can tell you the good and the bad that they have seen. Listen to them and take what they have to say seriously. Rewrites are very risky and can give you even more problems than you had before. If your team insists that they will work on their own rewrite, there is a strategy that you can use. Rewrite a program slowly and incrementally over time in place with the existing application. Martin Fowler calls this the Strangler Fig pattern, named for this plant species here. What is a Strangler Fig and how can it relate to software? Let's see. The general idea is that we want to replace what used to exist, like a tree in a forest, with a new modern structure that takes its form, like the fig that grows. So let's take a look in detail and see how that's true for our fig here, as well as our software. So we start with a tree, or our legacy application, the default state in our beginning. The seeds of the Strangler Fig germinate atop other trees and grow their roots downward as well as upward. They slowly start covering this tree. In our software analogy, these roots would be referred to as our Strangler Fig facade or wrapper. The facade will intercept requests for our legacy application, but to start out, it's basically just going to pass the commands right on through. In this VB6 example we have here, we can create a class library in .NET that can be registered for COM interop and imported as a reference in our VB6 project. Now this is actually more of an example in the reverse direction, where the outer facade is still VB6. This might still have merit as we start out, especially if the UI is complex in our VB6 and we want to test the waters. But we would eventually want to create that facade in .NET instead, as we'll see later. So back to our fig. As these roots grow down, they absorb the sunlight and moisture that they can find. This is even true for the sap within the host tree itself. This allows the roots to grow larger, which is weakening the tree. So back to our software analogy, this refers to the notion that now that we have a facade that is wrapping the requests to our legacy application, we may decide to take one request and bring it into a modern context. So we can do that while keeping the other legacy functions intact as they are. We're slowly moving the capabilities of this application into our new environment and shrinking the footprint of our legacy application. Even better yet, now we can use test-driven development to define the behavior that we see in VB6 and would like to have in .NET, and I can use that to drive the writing of the new code. Once that is done, I can safely call my new .NET method from the VB6 method, as we can see here. So this process continues. Our fig has cut off the host tree from all sources of sunlight and moisture. At this point, it's difficult to even see the original tree. Just like how our legacy application is still having its features moved into our modern environment. At this point, our facade has been built in .NET, and we brought the functionality from the class library into this new executable. We still have some legacy code left to handle in VB6, but we can call that from .NET. Everything has just about taken its final shape, but there's still a bit to go. So what is the end goal? Our fig is finished when its structure has completely replaced the original tree. It has killed off the tree, and if you look inside, you may find it to be completely hollow where there was once a tree. We still have the appearance of a tree on the outside though, because the fig has taken the shape of the tree. Just like how the hopeful end goal of our application is that the modern application is ready to stand alone. All legacy components can be retired, and the facade is no longer just a facade and is a fully fledged modern application that we can start doing cooler things with. We can actually import SVG images and have them dynamically size as the form grows. But one thing to really keep in mind here, I really want to make this clear. This is a very complicated and risky process, and it does not always go well. If done unsuccessfully, we're now stuck supporting a solution that is much more complicated than what we had in the beginning. But if a rewrite is required, making smaller bets and making incremental progress may be safer than alternative approaches. And if all goes well, here we would be. So as I was saying in the beginning, I wanted to make sure that we spent some time thinking forward. We can reflect on things from our past that could have been better. So how will we improve for next year? Well, I wanted to share with you some of my New Year's resolutions on technical debt. In 2022, I resolve to identify areas of improvement and help schedule them. Does this mean that we have to update Angular to version 13 right now? No, but we should probably be on 12 for now. And I'd like to be on version 13 by the time 14 comes out, but we have some time. We can schedule it in. If we only ever work on maintenance and technical debt, we never give ourselves the time to actually do the things that such maintenance makes easier. So get the balance right and keep an eye out for things that will benefit us in the future. I will attach maintenance tasks to new development items. When I see those opportunities come up, collaborate with management and product owners. Get them to see the value in what needs to be done. Show them how it will actually help them. Sometimes you slow down to speed up. Taking twice as long to do one feature might make future features take half as long. I will speak up when I see a technical debt red flag. If someone on the team keeps taking all the items in a certain area so that no one else can be trained on it, or someone else is advocating for developing things in such a way that will cause headaches, I will speak up. As I said, none of these are rules that absolutely must be followed, and it's okay to make a quick shortcut here and there. But if I see something that looks like we are heading down a bad path, I will say something and make sure that the team sees the things that I see, because maybe they haven't been seeing things from the perspective that I can see. At the same time, I will be a better listener and will listen for times where they have justification. I will write better unit tests so that I can refactor safely. I say better because it's not enough to just have more unit tests, because they should be effective unit tests. But having good unit tests can give us great feedback if we start refactoring things incorrectly. Also, if you find that it's hard to write unit tests because the code is not well architected, that goes back to the other points, because you identified more weak points in the code base, and maybe being able to address those will help us with something coming up. Finally, in 2022, I resolve to clean up my kitchen more regularly. Okay, so that was an analogy, and I swear my kitchen is never that bad, but I could always be better. Some of these time management issues are really applicable in multiple contexts. So inside or outside of the kitchen, I resolve to keep an eye on the items in my to-do list and consider what is urgent and should be done now or delegated to someone else, and which tasks are not urgent but are very important and should not be delayed too long before they are taken up as well. And that is it. So thank you so much. I hope that you learned something and are inspired to take another look at how maintenance of your software can be very beneficial for the long run. Again, these slides and the code shown for rewriting and refactoring can be found at chrisstone.dev. Please feel free to add me on any of my social platforms with links on my website. And you can reach out if you had any questions or feedback. And please check out the rest of the videos here on the Festive Tech Calendar and enjoy your holidays. Happy New Year!